Welcome to the deep dive. Today we're jumping straight into a crisis that has basically redefined digital advertising.
It really has.
We're talking about the death of the cookie and this new era of the privacy sandbox.
Right.
And our mission really is to get our heads around this signal loss crisis. The simple logic we all use for a decade is just gone.
Or that whole idea of user visits a site, a cookie gets dropped, you see them later on social media with an ad.
That's the one. It's fundamentally broken now.
And signal loss is exactly what it sounds like. It's the direct result. Because of all these privacy updates, the browsers themselves they're actively blocking or deleting those little tracking markers.
So in practice, what does that mean?
It means if you send, say, 100 conversion events from your website, the ad platforms, they might only actually see 60 of them, sometimes fewer.
Okay, so let's name the adversaries here. We need to talk about the systems that fired the first shots, starting with the browser engines.
And you have to start with Apple, with ITP, or Intelligent Tracking Prevention, in Safari and on iOS. It's fascinating, really. It uses machine learning to just figure out which domains look like they're tracking you.
And the impact is huge.
Oh, it's staggering. It does two big things. First, your normal third-party cookies blocked instantly.
But the real kicker is the first-party cookies, right? The ones on your own site?
Exactly. ITP puts a cap on their lifespan. Just 7 days.
Only 7 days.
And it gets worse. If the user came from a known ad link, with a Gclid from Google, that lifespan drops to just 24 hours.
Wait, so if my sales cycle is longer than a week?
Then for attribution purposes, it just doesn't exist. Someone clicks an ad on a Monday, thinks about it, and buys 8 days later. That conversion is attributed to nothing.
Zero.
You're just flying blind. Now, Firefox has ETP, which is similar, but let's talk about Google. They're taking a different approach with the privacy sandbox. Right, so Google's also getting rid of third-party cookies, but instead of just blocking everything, they're trying to replace them with these anonymous APIs.
Like topics.
Exactly, like topics, which groups you into broad interests, or protected audience, which is a way to do remarketing without actually tracking individuals across different sites. It's a whole different philosophy.
So if the browsers were the first wave, the mobile operating systems, they really dropped the heavy ordnance.
Oh, yeah.
Let's talk about iOS 14 and ATT. App tracking transparency. This was the nuclear bomb.
It absolutely was, because it forced user choice. When you open an app like Facebook now, you get that pop-up.
The famous prompt.
Allow Facebook to track your activity across other companies' apps and websites. And the key stat here is that something like 90% of users
90%.
click Ask App Not to Track. That one click strips away the IDFA, the identifier for advertisers. And just like that, cross-app tracking is essentially gone.
So if 90% of your audience opts out, how is any measurement even possible anymore?
Well, you're mostly guessing, extrapolating from that tiny 10%. But what it really forces is a complete change in architecture. The old way browser pixel talking to an ad server, it's just too unreliable now.
This is where it gets really interesting for me. The browser is no longer the source of truth. So what's the new mandatory way forward?
It has to be a hybrid model. It's built around server-side communication.
Okay, break that down.
You still have the client, the browser, talking to the new privacy APIs, but you must also have a secure, direct connection from your server to the ad platform's server. Think your Shopify server talking directly to Facebook's Conversions API.
So the logic moves somewhere. The ad blockers and ITP can't touch it.
Exactly.
So for a practical takeaway, what should you do? You can actually audit your own cookie health.
You can open up Chrome DevTools, go to the Application tab, and look at a cookie like FBP. Chrome will likely tell you it expires in 2 years.
Which sounds great.
But then, and this is the crucial test, you have to look at that exact same cookie in Safari.
And what will you see?
You'll see the truth. ITP will show you that hard cap of 7 days. Chrome is actively misleading you. And even for things like local storage, which some trackers move to, ITP is starting to clear that out too.
So relying on client-side data is just not an option anymore. You're forced to migrate all of your trust to these server-side systems. This shift, it completely redefines how you even gain knowledge about your customers. The data you thought you owned is now perishable. And if you're not listening server-side, you simply don't know the full story.
Okay, let's unpack this. We are doing a deep dive today into something that really fixes decades of instability in e-commerce tracking.
Yeah, a long time coming.
We're talking about Shopify's new Web Pixels API and this whole sandbox architecture. Our mission is just to grasp why this isn't some minor feature. This is like critical new plumbing.
It is.
It's turning tracking from this messy, fragile process into something secure, predictable, and, standardized.
And the key takeaway, really the thing to understand right away, is that your tracking code, your Google tag, your metapixel, it just no longer runs on the main storefront page at all.
That's the whole game right there. That isolation, that's a sandbox. So the old way was what, like one big messy kitchen, every script fighting for the same oven space?
Yeah, that's a good way to put it. And the new way, the sandbox, is this totally isolated environment. Shopify creates a separate, dedicated iframe.
Okay, and that's served from somewhere like Web Pixels Manager. I've seen that in the network tab.
Exactly. And the mechanism is, it's designed to guarantee data delivery. So when a user clicks a product, Shopify's core system commits a standard event, something like product viewed.
Right.
That data is passed securely into the sandbox, where your pixel's just listening. And only then does it fire off the request to Google or Facebook.
And this is where the security and performance benefits just become, well, huge.
Oh, massive.
Because it's isolated, the pixel literally cannot scrape data from the main page.
It can't. It has zero visibility into, say, credit card fields or any other sensitive info.
So it only sees the clean, curated data that Shopify explicitly gives it.
Exactly. And performance gets an immediate boost because this all runs on a separate thread. So you don't get that stuttering, slow scrolling effect, that janky performance.
Right, which everyone hates.
And look, for anyone using Shopify's new checkout extensibility pages, this isn't just a nice to have, it's the only way tracking works there. The old scripts just fail.
Okay, so we have this security blanket of isolation. The next logical step seems to be fixing the actual data chaos, the standardization.
Yes.
So you no longer need to write that fragile, document.query selector nightmare code to guess what a customer is doing.
That's the guarantee of data integrity right there. Shopify gives you this rich data schema, and pixels just hook into these common, clearly defined events.
So a product viewed on Shopify is just view content for the metapixel.
Precisely. Checkout started maps to initiate checkout. Checkout completed is, of course, purchase. It's one-to-one.
And the data you get must be pretty rich then. If you look at an event, what's inside?
You get a really clean data object. For a purchase, for example, you'll get the currency code, the price, and the exact product title like red shoes, all guaranteed to be accurate.
So it just eliminates all the guesswork and the validation headaches?
It guarantees the quality of your analytics. You're not hoping the data is right, you know it is.
But what if you have a special case? Some bespoke tracking need that, isn't a standard platform?
You can still do it. You can create custom pixels right in settings under customer events. You could send data to a custom API endpoint or just, log it to the console for debugging.
And that ties into the whole privacy and compliance picture, right?
It does. This whole system is, by design, consent-aware. If you have a cookie compliance app installed, the Web Pixels API just won't fire until the user actually accepts cookies.
So privacy is baked in, not bolted on.
It's privacy by design. And you control the access level. When you subscribe to an event, you set the permission. You can set privacy, analytics, or, for a higher level, privacy, marketing.
So it ensures legal compliance is the default setting.
Exactly. It's not an afterthought.
Okay, so let's sum this up. Shopify has basically solved tracking instability by making it isolated, standardized, and privacy-respecting. I mean, it's a massive structural win.
It is robust, but that isolation means testing can be, surprisingly tricky. Out of sight also applies to the developer console.
Right. So let's leave you with a final thought, a bit of a challenge.
Yeah, little puzzle.
If you were to build a simple debug tracker to just log all events using analytics.subscribe, given the isolation we've been talking about, what's the one key step you'd have to remember to actually see the output?
Because you won't see it in the normal console view.
You won't?
You have to remember to switch contexts. In your browser's console, you have to find that little drop-down that probably says top.
And switch it to the sandbox frame.
You have to switch it. You have to explicitly select the specific Web Pixels Manager sandbox frame. That's where your code is actually running. That context switch, that's the secret handshake to debugging in this new era. Okay, let's unpack this. We are diving deep into a crucial shift in digital advertising.
A really important one.
We're talking about server-side tracking, and specifically the conversion API, CAPI, because the standard way, the browser-based pixel, well, it's officially unreliable now. It fails all the time.
All the time. You have ad blockers, you have Apple's ITP intelligent tracking prevention. Even just a poor connection can stop it from firing.
ITP is huge.
It is. So the old model was basically your browser telling Facebook, hey, I just bought some shoes.
And the new model?
The new KPI model is your server, your Shopify backend, telling Facebook directly, user ID 123 just bought shoes. The key here, and this is fascinating, is that it's 100% reliable.
Because the user can't block it.
Exactly. It's completely invisible to them.
Okay, so that reliability is massive, but it brings up some big technical questions. How do we get that benefit without, say, losing important data or, and this is the nightmare, double counting every single sale? That's our mission for this deep dive. So the obvious question then is, if KPI is so reliable, why not just ditch the old browser pixel completely?
That's a great question. And the answer is that the gold standard is actually what we call hybrid tracking. You use both.
Both? Why?
Well, the Pixel is still much better at one specific thing, matching browser cookies. Think of the FBP cookie. It's native to the browser.
Right.
API can't see that. It has to rely on hashed user data, like an email or phone number, to find a match. So you want both data streams for redundancy.
But, and here's the problem, sending an event twice, once from the browser, once from the server.
Yeah.
That's going to look like two different sales to Meta.
That's the deduplication problem, exactly. And the fix is actually pretty elegant. It's the event ID.
The event ID.
Yeah. Your shop, let's say it's Shopify, it generates a totally unique ID for that one transaction. Call it Order 1001. Okay. That single unique ID gets sent with both the browser event and the CPI server event.
Ah, so Facebook gets two signals, but they have the same fingerprint on them?
Precisely. It sees the matching ID and just discards the duplicate. It usually keeps the one with more data, or it defaults the CPI one if the pixel was blocked.
So that brings us to the implementation part. On Shopify, for example, what are the real-world options here?
You've basically got three paths. First is the native integration. It's free, one click, but it's a total black box. You have no control over what data gets sent.
No customization.
None. Then you have third-party CPI apps. They can be costly, but they often have better data layers and can really boost your match rates.
And the third way?
The third is what I'd call the architect's way, a custom KPI setup. You build your own function, maybe an AWS Lambda or a Cloudflare worker that listens for Shopify webhooks like order screen.
Okay, but why go through all that trouble? Why build something custom when you could just click a button?
One very specific high-level reason, if you sell restricted goods.
Like what?
Think CBD, certain supplements, adult content. You need that level of control to strip specific keywords out of the data before it ever hits Facebook's servers.
To avoid getting your account banned.
Exactly. It's a compliance shield.
That immediately makes me think about PII, personally identifiable information. If we're sending data from our server, we have to talk about privacy.
We do. And this part is absolutely non-negotiable. It's a mandatory requirement from Meta.
What is?
Any PII, you send in a manual KPI payload email, phone number, name it must be hashed, specifically using the SHA 256 algorithm.
And if you don't?
If you send raw, unhashed text, you'll get a very serious privacy warning from Meta almost immediately. It's a huge headache you do not want.
So, to pull this all together, MAPI is like a reliable insurance policy for your tracking. But it's not a silver bullet. It needs to be coordinated really carefully with the browser pixel to work right.
That's the key takeaway. It's a partnership between the two systems.
And that leaves a really practical thought for you, the listener, to take away and apply.
Right. When you go to test this architecture and you look in your Facebook Events Manager, here's what you're looking for. You want to see that purchase event with the connection method labeled as server. That's step one.
And the crucial part.
The crucial part is seeing the status next to it labeled deduplicated. When you see that word deduplicated, that is the proof. That's how you know the entire complex system you just built worked absolutely perfectly.
So with these 2024 regulatory deadlines, it feels like understanding consent mode V2 is basically mandatory now for anyone operating on a global scale.
It really is. There's no getting around it.
So today, we're here to give you the shortcut. We're going to extract the practical knowledge you need to stay compliant and, properly informed on your data architecture. Okay, let's unpack this.
Right. To start, you have to distinguish between the two core legal frameworks that are driving all of this.
Okay.
In the EU, you have GDPR, which is strictly opt-in. I mean, you literally cannot track a single thing until the user clicks accept.
And that is just fundamentally different from the U.S. approach, specifically CCPA and CPRA in California, which is opt-out.
Exactly. They track by default, and they only stop if a user goes and finds that "Do Not Sell My Info" button.
And it feels like the whole thing reached a boiling point with the EU's Digital Markets Act, the DMA.
That's the 2024 law. That's the one forcing the big platforms, Google, Meta, Tala, to actually prove they have explicit user consent before using data for ads.
Okay, so that leads to a huge misconception. A lot of business owners I talk to, they just assume V2 is like a mandatory update to their banner app. Why is that just fundamentally wrong?
Because V2 is not a pop-up. It's a tag signaling system.
A signaling system.
Yeah, when a user clicks on that cookie banner, doesn't matter if it's OneTrust or CookieBot or whatever, that banner is relaying the choice back to the Google tags using 4 specific signals.
Right. So you have ad storage and analytics storage, which we've kind of seen before.
Yep, the old ones.
Plus the 2 new V2 additions, ad user data and ad personalization.
And those 2 new signals exist purely for DMA compliance. It's the law forcing the code to change, forcing that granular consent for ad personalization.
This is where it gets interesting with what's called advanced mode. So when a user denies consent, you aren't actually flying completely blind.
Not completely. The Google tags still fire, but what they send are these tiny cookieless signals. We call them pings.
And these pings have no personal identifiers at all.
None. Instead, Google uses AI to model the lost data. So the system looks at the behavior of users who did grant consent and, well, it applies those patterns to the denied traffic.
So it's an estimate. It's like, okay, we saw 100 pings, so our AI model estimates that you probably had about 12 conversions from that group.
That's exactly it. It's how you get some data back without breaking compliance.
But the complexity then moves straight into installation. For anyone on a platform like Shopify, the architecture leans so heavily on their native customer privacy API.
It does. That API sets the user's default state, maybe to marketing, undefined, and that's what keeps your GTM tags blocked.
Until the CMP app, the banner app, updates that API, GTM sees the change, and then it unblocks the tags.
And that's where the debugging headaches start. In Google Tag Manager, the key step is in your admin settings. You have to check the box for Enable Consent Overview.
Okay.
That feature is what lets GTM read the consent choice before it fires the tags.
That's okay.
Then on your tags, like your Google Ads conversion tag, you have to explicitly require consent for ad storage and adducer data.
And the final check, the one everyone has to do, is in the GTM debug tool with Tag Assistant. You have to see those signals flip from denied to granted right after you click Accept.
You have to. If that flip doesn't happen, your ads just won't run in Europe. Simple as that.
And it's important to remember this signal isn't just for browser tracking.
No, it applies to KPI too, your server-side conversion API. This connects V2 to all your advanced tracking methods.
Which brings up what I call the architect's dilemma. If you use a backend event, like a Shopify orders create webhook, that server request doesn't naturally contain the user's consent choice.
It doesn't.
So wait, if the webhook doesn't carry consent, aren't you risking sending, say, personal purchase data to Facebook's KPI without the legally required consent?
You absolutely are. That's the risk. The real-world solution usually relies on the client side, on the web pixel, to check the consent state first.
Okay, so the browser confirms consent.
And then it signals that status to the server, maybe with a custom header or parameter. That ensures the server only processes events for KPI if marketing consent was actually granted.
So to wrap this all up, what this really means for you is that Consent Mode V2 is the non-negotiable technical language for global advertising now. It's the framework that translates these very different laws into code that actually works.
And that leaves a pretty important question for you to think about. If this whole architecture relies on AI modeling to fill the huge data gap when users deny consent, what does that really imply about the accuracy of the conversion data you're using to make these huge multi-million-dollar decisions? Are you really confident trusting modeled data versus data you actually observed?
Welcome to the deep dive. Today, we're going way past the basics of just installing the Metapixel. We're getting into the real engineering guts of an advanced Meta KPI architecture, stuff that actually makes a difference.
Right. We're talking about signal quality, the data points you absolutely must have, and the architectural choices you make up front.
So let's frame the mission.
Yeah.
What's the one thing we need to understand today?
It's pretty simple, really. There are 2 main ways to implement this API, and it all boils down to one question. How does Meta know who actually bought something long after they clicked an ad?
Okay, so let's start with those 2 architectural paths. There's option A, the convenient route.
That's the one where you let your platform handle it. Think Shopify's native integration talking directly to Meta's servers.
It's easy, but you're giving something up.
You're giving up control. You're basically trusting the vendor's logic for how they map user data when they send it. It's a black box.
Which brings us to option B, the KPI gateway. This sounds a lot more involved.
It is. This is where you spin up your own self-hosted cloud stack, usually on AWS, using a container Meta provides.
That sounds like a serious engineering lift. I mean, you've got an AWS bill, you have to worry about server uptime. Is it worth it?
Oh, 100%. The payoff is huge, especially with cookie resilience.
How so?
Because the URL is a subdomain you control, like kpig.yourbrand.com, the cookies it sets are first party.
Which Safari and other browsers trust way more.
Exactly. It's a massive deal for tracking longevity. Plus, you get total data control. You can filter out PII, personally identifiable information, before it ever leaves your cloud.
Okay, that makes sense. So let's talk about identity. You can send a server event that says an order happened, but that's just noise if Meta doesn't know who did it.
It's completely meaningless. They need to connect it to a person.
Right.
And for that, there are two critical IDs you have to get right in the payload.
What are they?
First is the FBP cookie. That's the browser ID. But the one for attribution, the real key to the kingdom, is FBC.
The click ID.
The click ID. It contains that FBCLID parameter that Meta adds to the URL when someone clicks your ad.
And that's the engineering challenge, right? That click might have happened pages and pages ago.
Yes. So your client-side code, your JavaScript, has to grab that FBCLID from the URL the second the user lands and save it.
In a cookie or local storage.
Right, because your server is going to need it way later when the purchase actually happens, and that original URL will be long gone. You just cannot lose that parameter.
Okay, another big challenge, deduplication. We're firing a pixel event from the browser and a CPI event from the server. They have to match.
And they need to share the exact same evented and event name to be deduplicated correctly.
So how do you solve for that? It sounds like a race condition.
It is, and this is where most people get it wrong. They let the server generate the unique ID for the event.
Which will always be different from the one the pixel generated a split second earlier.
Always. And deduplication fails. The solution is the client, the browser, has to be the one to generate the unique ID. Then it passes that ID, say Wood 555, to the server in a hidden form field or something.
And the server just reuses that same ID for its KPI event.
Exactly. The source of truth shifts to the front end for that ID.
So after all this plumbing, how do you even know if you did a good job? How do you grade your signal quality?
You go into Facebook Events Manager, then Data Sources, and find event match quality.
Yeah, what's a good score?
You really want to be above a 6.0 out of 10. Anything less, and you're leaving money on the table. I saw a client score tank once. They lost nearly a third of their tracked conversions overnight.
Wow. And what was the cause?
A new clean URLs app they installed. It was stripping the URL parameter.
So if you look in that quality breakdown, what's the one red flag that just screams, my attribution is broken?
It's the FBC score. If you see that your FBC parameter match quality is at or near 0%,
you're not getting the click ID.
You're not getting it, period. Your attribution is broken. And the fix is almost always what you just said. Some redirect or app is stripping that FBCLID before your code can even see it.
This really makes it clear. Your technical architecture choices have a direct line to your marketing ROI. It all seems to circle back to just one thing, making sure Meta knows who took the action.
Yep, and think about this. We've established that the browser is the true source of that critical identity piece, that initial click. So if the client side is the source of truth for identity, how does that change the way you think about the reliability of the rest of your server data? It's something to really mull over.
A great thought to end on. Thanks for joining us on the Deep Dive.
Welcome back to the Deep Dive. Today we are really getting into the weeds of meta advertising engineering.
We are. We're talking about event match, quality EMQ, and specifically data normalization.
Right. And the mission here, for you listening, is pretty straightforward. Get that EMQ score above an 8.0. I mean, that's how you directly lower your cost per acquisition.
It's the whole game. And really, it's about preventing what we call orphaned events. You know, a sale happens, you paid for the click, but Meta can't attribute it. It's just gone.
And the technical reason for that is pretty interesting. You're not actually sending an email address or a phone number to Meta.
No, never in plain text. You're sending a hash, a SHA-256 hash, which is like a unique digital fingerprint of that data. Meta then tries to match that fingerprint against its own database.
So it's a comparison of your hash versus their hash, and if there's no match, There's no credit for the sale.
And this is where everyone gets tripped up because hashing is just pure math. It's incredibly brutally case sensitive.
That's the aha moment, isn't it? The idea that one tiny change can break everything.
Exactly. So think about the hash for John at example.com, all lowercase. Now, what about the hash for John at example.com with a capital J?
They're going to be completely different. Not even close.
Not even in the same universe. And because Meta stores everything on their end in a perfectly normalized lowercase format, if you send them a hash of John with a capital J, you get a 0% match rate.
It just fails.
It fails completely, all because of one character you didn't normalize before hashing.
Okay, so let's get practical. Let's build the checklist. For anyone setting this up, what are the absolute must-dos for, say, email and phone numbers?
For email, it's non-negotiable. You have to trim any white space from the beginning or end, and you must convert the entire string to lowercase.
No exceptions.
0 exceptions. And for phone numbers, it's a similar idea. You strip out everything that isn't a number, no symbols, no dashes, no spaces. And critically, you need the country code.
Right, so it shouldn't look like a standard U.S. number. It should be a clean string, like 1555, 1234567.
Exactly. And honestly, we even see good EMQ lists from doing the same to other fields. City, state, zip code.
Yeah.
Just lowercase them. Remove the spaces. The more you clean, the better.
That level of technical hygiene is just, it's amazing how much it matters. So once we have this perfectly clean data, how does Meta prioritize it? What's the most valuable signal?
Email is still king. A hashed email is the strongest signal you can send.
Okay.
Hash phone number is a very, very close second. After that, you get into other things, like the FBC parameter, the MetaClick ID. That's a really strong deterministic match.
And the weakest signal would be something like an IP address.
Right, IP address plus user agent. That's more of a probabilistic guess, a fingerprint. It's useful, but it's not a guaranteed match like hashed email is.
So we've made these changes. We've fixed our capital J's problem. How long until we see if it worked? How do we audit this?
You'll see it pretty quickly. You need to go into Events Manager, give it about 24 to 48 hours for the new data to process, and then look at your purchase event EMQ scores.
And is there a specific red flag to look for? A warning sign?
Oh, yes. There's a very specific one. You scroll down and look for a warning that says, server sending invalid email parameters.
And that's Meta telling you directly that you messed up.
That is Meta's system screaming at you that it's seeing formatting errors. It's finding a space or a dash, or most of the time it's finding an uppercase letter that you forgot to convert. We've seen attribution change overnight just by fixing that one warning.
So it really does all come down to something as small as converting a single letter to lowercase before you hash it. That's the line between profit and, well, an orphan data point.
It is. The precision required is immense. But here's a final thought on that. The whole system, this entire beautiful, precise machine,
Yeah.
it works on one huge assumption.
Which is?
That the email your customer used to buy something on your website is the exact same email they use for their Facebook or Instagram profile. Your engineering can be perfect, absolutely flawless. But if the user types in their work email at checkout and their meta profile is under their personal email, all that work, all that precision still results in a failed match.
You can't control for human behavior.
Not completely.
Oh.
But you can control your code. So if you're running server-side tracking, you really need to go audit your normalization rules right now.
Yeah.
Your CPA will definitely thank you for it.
All right, welcome back to the deep dive. Today we are going to solve one of the most painful conflicts in e-commerce advertising. How do you keep your storefront perfectly tuned for SEO while also writing ad copy that actually gets clicked?
Yeah, that is the big one. It's the core of what we call the sync problem.
Yeah.
See, the native integrations, they just push your product data as is. So your Shopify title, which might be just red shirt for SEO reasons.
No, it's your ad title.
Exactly. And to get a good click-through rate, you need something much better like red shirt organic cotton bestseller.
Yeah.
But if you change that on your storefront, you can absolutely destroy your SEO.
So we're essentially creating two different versions of the truth. One for the customer on the site and one, a more optimized truth for the ad network. But I have to ask, doesn't building a custom feed like this just open you up to a world of manual maintenance headaches?
That's a fair question, but that's where the smart architecture comes in. The whole mission here is to build a custom feed. It's a separate data file. And the really brilliant part is you don't need an expensive app. You can just use Shopify's own Liquid engine. It's already built in, and it's free.
Okay, let's unpack that architecture. You're saying we build an XML file using Shopify's own templating language.
Exactly. It's really just 3 core steps. First, you make a smart collection, let's call it Facebook feed, and you put all your products in it. Second, you create the liquid template file. That's templatescollection.xml-feed.liquid. And the key things here are templatescollection.xml-feed.liquid. And the key things here are Google tags if we're building this for Facebook.
That's the key, because Facebook, and honestly almost every other ad network out there, they all follow the Google Merchant Center format. That G namespace is basically the universal language for this stuff. The output is just a URL that spits out raw XML for Facebook to read. Got it. Okay, that architecture seems solid for a full build. But what about, being agile? Say I have 1,000 products synced, but I only want to change the images for 50 of them for a Halloween sale. Do I have to redo the whole feed?
No, you absolutely do not. That is exactly what supplemental feeds are for. Think of them as patches. For those 50 products, you just make a simple Google Sheet with 2 columns, the product id and the new image link. You upload that tiny file, and Facebook just overwrites those 50 images. Your main feed and your website are completely untouched.
Wow, that's some serious surgical control. Okay, speaking of fixes, what about common data errors, like HTML in the product description?
Yeah, that's a classic. For that, you just use the liquid filters.html. Cleans it right up.
What if the image is too small?
You can force the size directly in the liquid code, something like imageroll.width.l224. And if you sell custom stuff without a GTIN or MPN, you just add identifier exists no to the XML for those items.
Okay, this is where it gets really strategic. Let's talk about using this to boost your best products, the bestseller custom label hack.
Yep. This is the fastest way to segment your catalog and bid smarter. The whole goal is to group your most profitable products so you can give them more budget. So we use what's called a custom label, specifically custom label 00. In your Shopify admin, you just tag your top 5 products with, say, bestseller.
And the template logic automatically sees that tag and turns it into an ad attribute.
You got it. You just add a little if statement to the template. If product.tags contains bestseller %. If it's true, the feed spits out the value top performer. Then, inside Facebook Ads Manager, you can create a product set filtered for items where custom label 0 is top performer and dedicate a whole campaign to just them.
So when you boil it all down, mastering your data feed is really the line between just having your store connected and, actually optimizing your performance. The ability to separate the marketing story from the storefront reality seems key.
It fundamentally changes how you manage performance at scale and, raises a bigger question. If you can use simple product tags to do this, what else could you do? Think about using Shopify meta fields or even the new meta objects to automatically categorize your entire catalog for ads. Moving beyond manual tagging, that's the real path to automation and better global ad performance. It's what you should be exploring next.
Something to think about. All right, go build that custom XML, and we'll catch you on the next deep dive. Okay, let's dive in. We've had a lot of questions about advanced e-commerce engineering, specifically around making social media ads will actually convert better.
Right, and the focus today is moving past that generic product page everyone just dumps their traffic on.
Exactly. So our mission here is to map out the technical blueprint for creating these highly dynamic targeted landing pages that match the ad creative one-to-one.
And the core strategy, the big shift, is this concept people are calling the ad wrapper. So instead of sending your traffic to, say, product screen,
the standard, boring page,
you send it to a campaign URL, something like campaign's TikTok acne angle. It's a completely different destination.
That ad wrapper idea it's so smart. It solves that classic disconnect between a really specific ad and a generic page. But wait, doesn't that create a huge data problem?
How so?
Well, how do you make sure the headline and video on this content page actually line up with the real-time price and, the inventory of the actual product? Okay. And that is the absolute core of the engineering. The wrapper has a dual function. It pulls the creative, the headline, the video from a meta object that you've set up for that ad.
Okay.
But, now the key part, it simultaneously pulls the commerce logic, the price, the inventory, the add to cart function from the actual product that's linked inside that meta object.
So it's a data fusion. It's merging content and commerce on the fly.
Exactly. It's a seamless fusion.
All right, let's get into the structure then. The container for all this is the meta object definition. What are the, say, 3 or 4 essential fields you absolutely need to make an angle work?
Well, you need your content fields, obviously. An internal name just for you to track it, a headline field, probably rich text. Then you need file fields for your hero video and maybe some social proof images.
But which field is the linchpin? The one that connects the content back to the actual thing you're selling?
That's the target product field. It has to be set up as a product reference, and you'd make it mandatory. That's the pointer to the real inventory. No guesswork. Right. And crucially, how does this data object even become a page with a URL that you can, click on?
That's a specific setting. Inside the meta object definition, there's a checkbox. Publish entries as web pages. You have to enable that.
And that's what gives it the campaign's URL structure.
Yep. Turns every single entry into its own landing page.
Okay, so we have the data. Now, implementation. We're building the template for this hybrid page. Architecturally, what is the single biggest choice a developer has to make to optimize for conversion?
Easy. The first, and I think it's non-negotiable, is you eliminate all distractions. In the template, you use custom code to completely hide the standard site navigation.
The header, the footer, all of it.
Get rid of it. You want a funnel, not a browse session? Keep their eye on the prize.
That makes total sense.
Yeah.
But we still have the fundamental technical problem. This isn't a normal product page. So how do you get the actual buy box, the variant selectors, the add to cart button to work correctly?
This is the buy box fix. It's actually a pretty elegant solution. Your standard product sections won't work, so you build a custom featured product section.
And instead of picking a product for it.
Right. Instead of manually setting it, you connect that section's product setting to a dynamic source, metaobject.targetProduct.
And that's the magic right there.
That's it.
The page it dynamically loads everything, the price, the options, all of it, pulled from whatever product was linked in the meta object entry.
Precisely. And the form that's generated automatically points the add to cart action to the correct variant ID of that target product. It just works.
So the practical application is you can have an influencer page like Campaign Sarah Picks with its own unique branding and social proof.
Yeah, Sarah's secret routine revealed or whatever.
Yeah.
And when you set up your ad in Facebook's manager, that's the destination URL you use. It's contextual content driving real, accurate inventory sales.
So to wrap this up for you, the listener, what this whole technique does is connect that hyper-specific ad creative directly to your live, accurate inventory data. It's using a content object to drive hard commerce.
And it makes you wonder, right, if meta objects confuse dynamic content and commerce logic this powerfully, what other customer touchpoints, beyond a simple product page, can you transform into a completely customized, high-converting experience?
Welcome to the deep dive. Today, we're really drilling down into the essential infrastructure for e-commerce tracking.
Yep.
We're talking Google Tag Manager and the absolutely critical data layer specifically for Shopify. Our mission is to get you from basic tracking to a clean architectural setup.
And it's so important. The old way, what everyone used to do is just stick all these scripts for, Pinterest, Hotjar, whatever, directly into theme.liquid.
Oh, it's a mess.
It's a total mess. It tanks your site speed and makes the code base impossible to manage.
Exactly. And the solution is GTM. Think of it as like a traffic cop or the middleware. Your site loads just one script, the GTM container, and then GTM handles everything else asynchronously. It loads GA4, Google Ads, all based on rules we define.
Like only fire the Twitter tag when the event is add to cart. Simple as that.
Okay, so let's unpack that. GTM is powerful, but it's essentially blind to what's happening inside Shopify, right? It can't just see a liquid variable like product.price.
Right, yeah.
So how do you bridge that gap?
That bridge is the data layer. It's a standard JavaScript array, window.data layer. It's the designated middleman.
Okay.
So your Shopify liquid code pushes structured data into this array, and GTM is just constantly listening for that push.
Listening for a specific event.
Exactly, an event like view item. Now, here's where it gets really interesting, and frankly, where 90% of people get it wrong. GA4 has a very strict recipe, a schema for its e-commerce data. If it asks for item name and you send product name, the whole thing is just ignored.
It just throws it out.
Throws it out as a binary mismatch. No data for you.
Wow. Okay, so that required structure feels incredibly granular. We're not just talking about a price. We're talking a top-level e-commerce object currency, a value.
And a nested items array.
And a whole items array with details for every single product, like item id, item brand, item variant. Is all that really necessary?
It is, yeah. If you want accurate reporting, if you want to build proper funnels, without it, you're just looking at page views, which isn't enough. But the good news is you only have to build it once. This is what you call the architect's way. You automate it.
Okay.
You use Liquid to generate that perfect JavaScript structure on the server. You'd use a snippet, maybe something like data layer-product.liquid. and just include it where it needs to go.
So once you've automated that, how do you check your work? How do you verify you haven't, missed a comma and broken the whole thing?
You have to use the GTM debugger and tag assistant. It's non-negotiable.
And what are you looking for?
Two critical things. Make sure e-commerce.value is a true number, not a string with quotes around it, like 29.99.
Okay, a common mistake.
A very common mistake.
Yeah.
And second, make sure items is actually an array. Get the data type wrong, and GA4 rejects it.
Got it.
And here's a pro tip. This will save you so much debugging time, especially with single-page applications or dynamic pages. The null reset.
The null reset.
Yeah. See, the data layer merges objects. So data from the last page can stick around and contaminate the new event.
Yeah.
The best practice is to clear it out first.
So you push a null value first.
Exactly. Window.datalayer.push. Commerce.null. And then you push your new clean data. It prevents that bad merge.
That structural integrity is that's everything, isn't it? Moving from that messy, hard-coded approach to this is the difference between having useless code and having clean data that you can actually use to make decisions.
It is, which raises an important question for you to think about.
Yeah.
Now that your data layer is structured precisely to GA4 schema, how will this clean, accurate data fundamentally change the events and reports you explore next?
Okay, so today we are doing a deep dive into something that sounds simple but is surprisingly complex. We're talking about tracking e-commerce events inside Google Analytics 4.
Yeah.
If you use digital ads to sell anything online, getting this right is basically the key to knowing if your campaigns are actually making money.
Exactly. And what's wild is that GA4 has this really strict reporting logic. You have to follow its rules if you want meaningful data, especially for something like return on ad spend, ROAS.
Right.
So our mission today is to just unpack that structure. And the key takeaway right up front is this. GA4 needs a perfectly linear story. If you skip a single step or you mess one up, the whole funnel just breaks.
You have to tell GA4 the story step by step. So the standard e-commerce funnel, it starts with view item, right? When someone lands on a product page.
Yeah, that's step one. Then you get into the middle steps, add to cart, view cart, begin checkout, and add payment info.
And it all leads to the final goal, the purchase event on the thank you page.
Yeah.
Is this super strict linear thing new to GA4? I feel like older platforms were a bit more forgiving.
Oh, absolutely. GA4 is way less forgiving. It demands precision. And this is where most people get tripped up, specifically with the add to cart event.
Why that one?
Because it's a user action, not a page refresh. Think about modern sites like on Shopify. You click add and the cart just slides out. The page doesn't reload. That's AJAX.
Okay, but why can't we just trust the button click? That seems like the easiest way to do it.
It is the easiest, yeah, but it's what I'd call the bad way. Let's say the user clicks the button, your tag fires, but the server has an error. Maybe the item just went out of stock. The tag's still fired. You've just recorded an action that never actually happened. Your cart data is now wrong. And if you use that for remarketing, your audiences could be inflated by like 30%.
Wow. Okay, that's a huge business impact. So what's the good way? How do we know for sure the item was added?
The right way is to use something called an AJX listener in Google Tag Manager. It's a bit of code that doesn't watch the click. It waits for the successful network response from the server, specifically a 200 OK status from that cartad.js API call. Only when the server confirms the action was successful does it push the event.
Okay, so that makes the data ironclad. It reflects confirmed action. But even with that, I've seen analysts get so frustrated with this one thing in their reports that dreaded not set value.
The classic. That is almost always an ID mismatch. It's a critical failure. Think of it this way. Your view item event sends in a SKU, like SKU123.
Okay.
But then later, your add to cart or your purchase event sends a totally different identifier. Maybe it's the Shopify variant ID, which is just a long number, like 123456789.
So GA4 can't connect the dots.
It can't. It sees one product being viewed and a completely different product being bought.
Right.
The user's journey is broken.
So if I view item A, but the purchase records item B, GA4 just sees a ghost. I can tell you from experience, trying to debug that feels impossible.
Exactly. But the fix is simple in theory, just, hard to execute. You have to pick one ID format, just one. Whether it's SKU or variant ID, I don't care. But you have to enforce it strictly across every single tag, GA4, Google Ads, Facebook, all of them. Standardization is the only way to kill that not set error.
Right. And this all leads to the bigger picture. The purchase event, that's the holy grail of all of this.
It's the only one that truly proves ROI. It has to fire once and only once, and it needs all those other pieces like transactioned, value, tax, and shipping to actually tie revenue back to your campaigns correctly.
So to wrap this up, the two huge technical takeaways for you are, first, demand network confirmation for dynamic events. Don't just track clicks. And second, standardize your item IDs like your job depends on it, because it probably does.
So here's a final thought for you to chew on. If that purchase event is the only piece of data that proves your marketing dollars are working, how much time are you actually spending to make sure its implementation is as bulletproof as that AJX listener we talked about? Are you positive it works every time without just relying on a simple and potentially faulty page reload?
All right, let's dive into something that I think is a really crucial architectural question for anyone in e-commerce. How do you feed Google Merchant Center all the data at once without just completely destroying the look and feel of your actual Shopify store?
That is the mission, because you see it all the time. People changing a beautiful product title, say luxury watch, to something awful like Rolex watch, blue face, fast shipping.
Right on the public site. It just looks terrible and spammy.
It ruins the whole experience.
Yeah.
And the only real scalable answer, is getting a handle on the supplemental feed architecture.
It's all about separating your data. What you show your customers should not be dictated by what a marketing algorithm wants to see.
Exactly. So the setup is actually, pretty straightforward when you break it down. You've got your primary feed first.
And that's just the standard Shopify, Google, and YouTube app, right?
Yeah.
Just syncing the basics.
Yeah, exactly. It's do the bare minimum ID, price, stock level. But then you bring in the supplemental feed.
This is the magic layer. A Google Sheet, maybe? Or for real power, a custom XML file. So what's the rule when they meet?
The rule is absolute. If a product ID is in both feeds, the data in the supplemental one always wins. It just overwrites the primary data.
But only inside Google Merchant Center.
Only for Google's eyes. So your storefront can say red sneakers, but your Google shopping ad can say, Nike Air Max 97 running shoes, red size 10.
Okay, and this is where it gets really powerful for scaling, isn't it? Especially for something like apparel.
Oh, absolutely. Google is so strict with apparel. It needs gender, it needs age group, color, attributes that might not be clean in your standard Shopify setup.
So you're not going in and editing 1,000 products one by one.
No, God, no. That's the beauty of it. You use logic.
For instance, if you're already using Shopify tags like men's or women's for your own internal collections,
you can just use a little bit of liquid programming in a custom XML template to say, okay, if the tag is men's, then write g.gendermelee.gender into the feed.
So the tag drives the feed. It's completely automated and separate from your store design.
And while you're in there, a great little hack we saw in the sources is for the title itself.
The G title tag.
Exactly. You build it dynamically.
Yeah.
Combine the vendor plus the title plus the variant. That gives you a massive lift in search relevance.
Okay, so that's compliance and SEO. But let's talk about the bidding strategy. This is where it gets really profitable.
This is where the custom labels come in. And they are, I'd say, non-negotiable for serious advertisers.
Because in Google Ads, for shopping or PMax, you can't bid on keywords. You have to bid on product groups.
Right, and Google gives you 5 empty labels, custom label 0 through 4, to create your own groups, groups that actually matter to your business.
And the examples from the source material were just perfect. For custom label 0, you could do price buckets, under $20, $50 plus, that sort of thing.
But the real moneymaker was using custom label 1 for margin.
High margin, low margin.
Think about the power of that. You can now literally tell Google Ads, I want to bid 30% higher on my high-margin product group. You're bidding directly on profit.
Not just on clicks or conversions.
Exactly. And it applies to everything. Take liquidation, for example.
Yeah.
You just tag a product with clearance in Shopify.
And the liquid logic you built sees that tag.
And automatically writes something like g.customlabel4, clearance.g.customlabel4 into the feed. Instantly, you can isolate those products for an aggressive campaign.
And once that custom file is built, what's the last step?
It's simple. You just paste that XML file's URL into Google Merchant Center, tell it to fetch the data every day, and you're done. It's a fully automated system.
So the core takeaway here is really clear. The real power is in building that wall between your internal brand data and your external marketing data. It's how you win on Google without trashing your store.
And that kind of leads to a final thought, I think. Since you have the power now to dynamically assign almost any business logic like high margin or clearance to a custom label, it raises a bigger question for you to think about. What other critical, maybe non-obvious data points like vendor return rates or inventory age or even shipping costs, what else could be engineered into those custom labels to make your bidding strategy even smarter and ultimately more profitable?
Okay. Let's get into it. For this deep dive, we're tracking a very specific journey. We're following product data from, say, a Shopify inventory system all the way to when it pops up on a YouTube video. And our mission here is to find and really conquer the biggest bottleneck in that whole process.
Right, and the first thing to get is that the system isn't just point-to-point. It's a whole pipeline.
A pipeline with some required stops along the way.
Exactly. The product goes from Shopify through an API or a feed into the Google Merchant Center or GMC.
And only then can it be tagged in YouTube Studio for a viewer to actually see.
Right.
And smack in the middle of that is what we're calling the latency trap. The standard API sync can take, 15 to 30 minutes?
It can. And if you're doing a live drop, a high-stakes launch, 30 minutes is just fatal.
It means your product is sold out before the shopping tag can even appear on the stream.
So the architectural fix, it requires you to bypass that default heavy sync.
How do you do that?
You have to go into your Shopify, Google, and YouTube channel settings and make sure instant sync is enabled.
And that uses a different kind of update.
A totally different one. Instead of the full product update, which has everything, descriptions, images, all of it, it uses a specialized inventory endpoint.
Okay, so tell me why that's faster. What's the practical difference?
It's all about the size of the data payload. A full product update is huge. The inventory endpoint, though, might only be updating the stock count.
So you're sending a whisper instead of shouting a novel.
That's a great way to put it. It takes the sync time from minutes down to just a few seconds.
That makes perfect sense. Now, even with that instant sync, a product can still be invisible, right? If the GMC feed is wrong.
Oh, absolutely. The product will not show up in YouTube Studio if the feed is missing a very specific tag.
Which is?
Is G included destination, YouTube shopping .included destination. Without that, Google just assumes the product is for, regular search ads.
And there are other failure modes, too.
Yes. YouTube shopping, right now, it requires physical goods. If the is-digital flag is true, the product just vanishes.
And the big one is stock.
The biggest one. YouTube instantly hides anything marked as out of stock. It's not delayed, it's immediate.
That real-time hiding is a really interesting pivot point because it connects to this massive growth area we see coming.
The affiliate architecture.
Linking Shopify collabs with the YouTube Shopping affiliate program.
And what's so fascinating from an engineering view is how it's built on trust. This system lets creators, even ones with no direct seller relationship, find and tag your product in their own YouTube Studio.
And Google handles the tracking?
Right. Google's Connect platform indexes the commission rate, say 10%. Then the Google Affiliate ID handles all the attribution and sends the conversion data back to Shopify collabs for the payout.
So let's talk about scale. A huge brand, maybe with 100,000 SKUs, their own site search is probably struggling.
It almost always is. And that's where you offload the intelligence to the Google Cloud Retail API.
So you send your GMC feed to Google Cloud instead of relying on your own search.
You do, because then you get to use the same AI that powers Google.com. It understands semantic intent.
Meaning it understands context, not just keywords.
Exactly. It gets a query like black dress for a wedding, not just the literal word dress. You trade a bit of control for, frankly, a much higher conversion rate because it understands what users actually mean.
So wrapping this up for you, the listener, the main takeaway is that these architectural limits really define your strategy. Understanding latency, understanding that out-of-stock items are hidden instantly, that's crucial.
It is. And this knowledge forces a shift in how you think. Since latency is a given and out-of-stock products are invisible, well, what if you focused not on making the product available instantly?
But on making it taggable before the stream even starts?
Precisely. Or just direct that initial traffic to a Notify Me landing page. You work with the architecture instead of fighting against it. That's the real advantage of going this deep. All right, let's get into a really crucial piece of e-commerce architecture today.
The added to cart event.
Exactly. We're going to dive deep into how the best marketing teams build a reliable trigger for, platforms like Klaviyo or Attentive.
And the mission here is really to figure out the technical fix. The one needed to close a huge high-intent gap in the standard e-commerce
funnel, right? The funnel. Let's set the stage there first.
Okay, so everyone knows the 4 standard steps, right?
Yeah.
You've got active on site, then viewed product.
And then started checkout, and finally placed order.
Precisely. And the gap, this high-value blind spot we're talking about, sits right between viewed product and started checkout.
And the difference in customer intent in that gap is just, it's massive.
Oh, absolutely.
I mean, if you look at a viewed product flow, so browse abandonment, the conversion rate is so low. maybe 1%.
If you're lucky. Looking is free, after all.
Right. But when someone actually adds an item to their cart, that's a real commitment.
And that's where you see conversion rates shoot up into the high single digits, sometimes even 10% territory. It's a whole different ballgame.
So what's the core technical problem here? Why is it so hard to track?
Well, the issue is that a platform like Shopify doesn't have a native, reliable server-side webhook that fires every time an item is added.
So the platform just doesn't tell you.
Not reliably. So if the platform won't tell us, we have to listen for it ourselves. And that means we have to inject a client-side listener.
Okay, wait a second. Why can't you just target the Add to Cart button with a simple click listener?
You mean like with jQuery or something?
Yeah, jQuery.btn-add.click. Isn't that good enough for most stores? It seems so much simpler.
It seems simpler, but it's incredibly brittle. It's fragile.
How so?
Think about it. You're relying on a specific button's class name. The moment a merchant updates their theme or just changes the button design,
Your tracking just breaks instantly.
completely breaks. So instead of listening to the theme's visual structure, we shift focus and listen to the network itself.
The network. Okay, so this is the AJAX interceptor architecture you mentioned.
Exactly. So here's how it works. A user clicks Add to Cart.
And the theme sends a hidden request to the server, usually to that cartad.js endpoint.
That's the one. And our custom script, it doesn't interfere with that at all. It just overhears the success response.
It's like a wiretap. You're not watching the front door. You're listening to the conversation in the back room.
That's a perfect analogy. We grab the entire payload of data, the product title, ID, price, all of it.
And from there, you just push it straight into Klaviyo's learn object?
Yep. Using a simple helper function, it's immediate.
Now, to make sure this works everywhere, you need two interceptors, right? Why two?
Right, for compatibility. You need a fetch interceptor for all the modern asynchronous themes.
Okay.
But you also need the older XHR interceptor to cover legacy themes that still use older AJAX methods. You put both into theme.liquid and you're covered.
And that technical rigor, it has a direct impact on the bottom line.
It really does.
Let's look at the math again. Something like 50% of users add an item to their cart.
Roughly, yeah. But only about 20% actually go on to start the checkout process.
Which means if you only use a checkout abandonment flow, you are completely missing 30% of your highest intent traffic.
You're leaving a huge amount of revenue on the table. That gap is where the money is.
And the beauty of this high-quality event is that it's platform agnostic, isn't it?
Absolutely. That exact same event. It isn't just for email. You can use it for SMS with attentive or PostScript.
You just swap out the function call.
You just replace learnQ.push with, attentive.analytics.track or whatever their function is. The reliable event is the real asset.
So we've used network interception to get past unreliable platform hooks, and we've closed that critical 30% intent gap. We have a robust, reliable trigger.
We do. But fixing the firing mechanism, that's really only half the battle.
What's the other half?
Well, think about this. To verify this event is even working, the user often has to be identified, right?
You mean like adding .emailtest@example.com to a URL?
Exactly. So here's the final thought. If you can get this network interception firing reliably, the next challenge, and it's arguably the harder one,
Go on.
is ensuring that all the tracking data from your anonymous users, that 30% who haven't logged in, is correctly resolved and tied to their identity later.
When they finally hit checkout or subscribe to a newsletter.
Right. That identity resolution, that's the true key to monetizing that commitment gap. Okay, let's get into it. We are doing a deep dive today into something really fundamental for digital marketing.
Identity resolution.
Exactly. We're going to try and give you the shortcut, right? The architectural tricks that turn those anonymous website visitors into, well, actual customers.
And it all starts with solving what the source material calls the ghost problem.
The ghost problem. What's that?
It's that first moment a user lands on your site, they get a cookie, something like a clade, and poof, they exist.
But only as an anonymous profile.
Right. You can see what they're doing, product views, clicks, all that.
Yeah.
But you can't email them. They're basically invisible.
So you have data, but it's not actionable. The real goal then, the whole point, is to force a merge between that anonymous history and an actual identity.
And to do it as fast as you possibly can.
So what's the one technical trigger for that? What makes it happen?
It's a specific API call, usually just called an identify call. That's the function that tells the system, hey, this anonymous cookie ID, it belongs to this email address now.
And here's where the architectural magic comes in, what the sources call the retroactive merge.
Yes.
So let's say a user views 3 products, totally anonymous. Then, for some reason, that identify command finally fires. What happens to that old history?
That's the critical insight. It doesn't just start tracking from that moment forward.
It goes back.
It instantly goes back and links those 3 viewed product events to the new profile. All that history is just absorbed. It becomes immediately actionable.
So once it fires one time, that browser is basically cookied forever, unless they clear their cache.
That's it. So the whole game becomes about triggering that event earlier.
Which brings us to strategy 1, URL parameter extraction. Seems pretty simple.
It is, but it solves a huge blind spot with returning traffic from, say, an email you sent. They clicked a link, but they might still show up as anonymous.
So the script just scans the URL.
Yeah, a little bit of front-end code,
Yeah.
looks for something like .email in the URL, grabs it, and fires that identify event right on page load. Problem solved.
Okay, that's the low-effort one. But what about strategy 2, the micro-conversion? Using quizzes. That sounds like a lot more work than just waiting for checkout.
Because checkout is way too late. You've lost so much opportunity by then. A quiz identifies them and segments them at the same time.
Okay.
Think about it. They answer a few questions, maybe about their skin type, and the gate is enter your email to see your results.
And that's the double action.
Exactly. The submission fires the identify call, so you know who they are,
Okay.
and it immediately fires a track event, like completed quiz, with a property like result, dry skin.
So now you can send them a follow-up flow that's hyper-relevant.
And the sources claim those convert 3 times better than a generic, you left something in your cart email.
Right. That leads to strategy 3, upgrading the back and stock logic. Usually that form just signs you up for one specific item, right?
Yeah, red shirt, size small. That's it. It's a local action.
So how do you make it global?
You change what the form submission does. Instead of just signing them up for a notification, you use that email to fire the global identify call.
So they're no longer just interested in the shirt, they are now user X across the entire site.
Exactly. So if they go browse, blue pants 5 minutes later and leave.
The system knows who they are and can trigger a browse abandonment flow for the pants.
The ghost is gone.
So really what this all means is that early identification isn't just some technical detail. It's the whole foundation.
It's a currency.
Yeah.
It turns all that passive tracking data into fuel for automation that actually works.
Absolutely. The sources show that something as tiny as a back and stop request can unlock a user's entire history and future behavior. So it really makes you think, doesn't it? What other minor forms or inputs on your site comment sections, review requests could be used to unlock that global identity and fundamentally change how you engage with every single click that comes after?
Okay, so for today's deep dive, I think we should really unpack a simple question.
And what's that?
What's the real difference between, say, a generic marketing email that gets maybe a 15% open rate and a hyper-relevant one that hits like 50%?
Right, the holy grail. And the answer really is all in the data architecture.
Exactly. We're going to cut straight to how platforms like, Klaviyo or Attentive actually structure their data to make that kind of thing possible.
And what's so fascinating here is that it all comes down to knowing 2 types of data. You've got your standard properties.
The basics.
Yeah, the absolute basics. Your email, your city.
Yeah.
The stuff that gets that automatic $ prefix.
But that's just table stakes. That's not what makes you different.
Exactly. The real goal, the architect's goal, is to get all that nuanced knowledge, the stuff that actually drives purchasing into custom properties.
Things you invent yourself, like skin type or favorite color or a B2B status.
Right. Moving that human knowledge into a tag. That shift is, well, it's the entire ballgame.
So how do you actually do that? How do you capture it seamlessly?
Well, the most robust method is probably using the JavaScript identify call.
Okay.
It's just so incredibly powerful because you can run it at any point in the journey, even if the user is, already known and logged in.
So give me a real-world example of how that works.
Okay, think about a preference center. A user literally tells you, hey, I'm interested in men's products. The website just immediately runs that identify call. It pushes shopping preference, men's, and maybe even adds a timestamp for last updated preferences.
So the profile update is instant.
instant and user-driven.
But that requires the user to tell you something.
Mm-hmm.
What about tagging them silently? Can you do that without asking another
Oh,
question?
absolutely. That's the whole hidden field strategy.
Right.
So let's say you have the same newsletter sign-up form in your footer and also on a dedicated landing page.
Okay, yeah.
You can just slip a hidden input field into the HTML. So when they sign up from the footer, it silently tags them. Maybe it sets the source property to footer v2.
The user has no idea. They just think they signed up.
Exactly. It captures that context without adding any friction.
Okay, so that's for simple forms. What about something more complex, like a company building its own custom quiz? One of those skincare routine finders.
Now, that's where you have to get your hands dirty, so to speak.
Mm-hmm.
Unlike an out-of-the-box app that does it for you, if you build that quiz yourself, you have to manually loop through all the answers like skin type, oily,
Right.
and then explicitly push that whole bundle of data to the platform before you even show them their results.
You're forcing the profile update.
You are. You're making sure that custom data is there and ready for segmentation immediately.
So what does all this mean? We've gone to all this trouble to capture this rich, custom data. This is where the payoff comes in, right?
This is the entire point. It's segmentation logic. This is where we stop, blasting generic audiences and start building these dynamic segments.
And the real magic is combining who someone is with what they've actually done.
Absolutely. So let's build one, a really high-value segment.
Let's do it. We'll call it oily skin high value.
Okay. So the definition would be a property about them, skin type, has to equal oily.
Got it.
AND, something they've done. Like their placed order value is greater than $100.
At least one time.
At least one time. Now you have this hyper-specific, high-intent group.
And you send only them an email about a mattifying clay mask.
And that is how you see those open rates just climb. You go from a generic 15% to maybe 50%. It's transformative.
So when you boil it all down, the real concept is that your data architecture, it basically dictates your marketing success.
It really does. It's about moving that specific, nuanced user information into these neat, manageable custom tags.
Which gives you that surgical precision.
Mm-hmm. And the thought I kind of want to leave you with is just how simple this can be on the back end.
What do you mean by that?
Well, just think about it. Your own profile on some platform right now, it likely knows your favorite color or the last product category you looked at.
Yeah, of course.
So just reflect on the ease of that. How a single tiny data point can be attached to your digital identity, and then how thoroughly that can be leveraged for hyper-personalization, shaping every single message you get from then on.
That is a powerful idea.
Yeah.
And this whole data strategy is really just the beginning.
It's the foundation.
Right. Sets us up for all the advanced stuff, transactional messaging, webhooks, all the things we'll be diving into next time.
All right. Welcome to the deep dive. So today we're tackling something I think a lot of people who deal with custom orders really feel.
Oh, absolutely. Manufacturing anything complex.
Exactly. If you need more than just a basic, hey, your order shipped notification, you know this pain. So our mission for this deep dive is to bridge what we're calling the logic gap.
Right.
How do you send those really specific, personalized updates to a customer's phone using API triggers?
And before we touch any of the tech, we have to start with the legal architecture. I mean, this is the foundation. If you get this wrong, nothing else matters.
Okay, so lay it out for us.
You have to, and I mean have to, distinguish between two types of SMS. There's marketing SMS and there's transactional SMS.
So marketing is if I want to tell them about a sale, and transactional is what? It's information they actually need for the order.
Precisely. Like your custom desk is now in the sanding phase. That's transactional. You can legally send that to anyone who gave you their number at checkout. But, and this is what I call the architect's rule, and it is the most critical warning, you can never inject marketing content into a transactional API call.
Not even a little bit. Like a, hey, buy the matching chair.
Nope. Not even that. Adding that little bit of promotional text is, it's just a catastrophic mistake. You risk getting your entire short code banned. It's not worth it.
Wow. Okay. That is a very high-stakes warning. And I guess that leads us right into the logic gap, because standard systems don't really give you that kind of precision.
They don't. Think about your standard SMS apps, Attentive, Clivio. They listen to the basic Shopify topics.
Orders create.
Orders create, orders fulfilled, yeah. They are completely blind to the stuff that actually matters for a custom product. They don't see your order tags like status, painting.
Or metafield updates,
Right.
or a status change from an ERP system, maybe.
Exactly. They see none of it. So to get that critical data out, you have to bypass their normal listeners and use something like a webhook or Shopify Flow to hit the SMS provider's API directly.
Hold on, though. When you say hit the API directly, doesn't that sound like we're moving from no code into custom code? Are we just trading the logic gap problem for a technical maintenance problem?
That is a great question, and not necessarily no. Especially if you're using a tool like Shopify Flow.
Yeah.
You let Flow handle the automation logic, but the API does the heavy lifting.
So the trigger could just be adding a tag?
Yep. You tag an order with, say, production, polishing. That's your trigger. The action is just telling Flow to send an HTTP request. That's a POST command write to an endpoint, like Klaviyo's Events API.
Okay, this is the payoff. This is what we've been waiting for. So if we're talking directly to the system, what information do we actually have to include in that request body to make sure the right message goes to the right person?
It's basically three things. First, you have to give the event a name, what Klaviyo calls a metric. Something like production update.
Okay, simple enough.
Second, you have to identify the customer. So you must include their email and their phone number.
The identifiers, right.
And third, you define the specifics inside the properties. This is where you put the ordered, the precise status polishing, and, the actual message text itself.
So that's where you get to write, your table is currently being polished by our master carpenter.
That's the magic right there.
And I'm assuming systems like Attentive can handle this kind of thing, too.
Oh, absolutely. The concept is identical. You're just pushing that hyper-specific event data to their API. For Attentive, I think you're targeting their V1 events custom endpoint.
Yeah.
And it just triggers a custom event in one of their journeys. The payload looks a little different, but the goal is the same.
So really what this all means for you, the listener, is that you get the power to deliver this incredible operational transparency, that moment of delight for your customer, and you're doing it while staying perfectly legally compliant.
100%. Because it's purely transactional information. And I guess that raises the final question, the thing to think about after this.
Go for it.
If you can connect a custom manufacturing status update directly to a customer's phone with just a simple tag and an API call, what other part of your internal process are you still hiding from your customer just because you thought it was too complicated to communicate?
Okay, let's get into this. We've all seen it, right? That little orange shopping basket that pops up in a TikTok video. But today we're going way past that, past the front end, and diving straight into the technical architecture, the back end stuff you need to actually run a TikTok shop when it's hooked into something like Shopify.
Yeah, and it's so much more complicated than people think.
It's not just slapping up a link.
Not at all. The fascinating thing is you have to forget the visuals for a second and just look at how it actually works. TikTok Shop uses a native checkout experience.
Meaning the user never leaves the TikTok app.
Exactly. They see the video, they click the basket, and they pay right there inside TikTok. And that creates this closed loop.
Hold on. So Shopify, which for most brands is the one source of truth for inventory, it's completely blind to a sale that just happened.
Initially, yes. It has no idea.
That sounds like a huge problem you have to solve from minute one.
It is the problem. That closed loop means your entire mission is to build a really, really solid bridge so those two systems can talk to each other.
And that bridge, it's not just one connection, is it?
No, it's 4 non-negotiable data flows. And, most of them have to be bidirectional.
Okay, let's define the handshake then. What are the 4?
So first you have product sync. That's pretty straightforward. Shopify pushes product details, images, descriptions, price over to TikTok.
The basics.
Then number 2, inventory sync. This one is way more complex. It has to be almost real time, and it has to go both ways to keep stock levels accurate everywhere.
So the products are synced up, but what about the sale itself? How does that order get back into Shopify, the system it bypassed?
That has the third flow, order sync. Once the customer pays in TikTok, TikTok has to push that whole order back into Shopify so your warehouse team can actually fulfill it.
And there's a 4th.
The final, and I'd say most critical piece, is the fulfillment sync. Shopify has to push the tracking information back to TikTok.
Why is that one so critical?
Because TikTok will not release your money, the seller's money, until it gets that tracking number and confirms the package has shipped.
Wow. Okay, it sounds like that inventory sync is where things could go wrong fast. If there's one tiny detail that causes the biggest mess, what is it? What's the golden key?
It's the SKU, the stock keeping unit. This is, without a doubt, the most common point of failure.
And the rule is what?
The rule is absolute. The SKU must match character for character. No exceptions. So if Shopify has, say, t-shirt red S, but in TikTok it's t-shirt red small, the whole sync just breaks. It will not work.
And I can see the disaster. Your video goes viral, TikTok can't find that product ID, so it assumes you have infinite stock, and suddenly you've oversold 500 shirts you don't actually have.
That's the nightmare scenario. And the only real fix is, well, it's tedious. Before you even connect the two, you have to export CSVs from both systems and do a manual audit, a VL OCUP, basically, to force them into 100% parity.
Okay, so matching products is one thing, but you also have to match where the products are, right? It's not enough to just say, we have 100 in stock.
That's exactly right. TikTok needs to make accurate shipping promises. So you have to map your Shopify locations to specific TikTok warehouses. You can't just sync a total. You have to sync, California has 60, New York has 40.
And even if you get all of that right, you're still up against the clock, the TikTok SLA timer.
Oh, yeah. TikTok is ruthless with its SLA. You usually get 3 days. 3 days to ship the order and get that tracking info back into their system.
And if you're late?
If that fulfillment sync is late, TikTok just automatically cancels the order. Full refund to the customer.
So wait, you're not getting penalized for shipping late? You're penalized for reporting that you shipped late. That's the latency gap risk.
It is. Your warehouse could be perfect, ship the item in an hour. But if the API call, the little bit of code that sends that tracking number back, if that fails or just gets stuck in a queue,
the order gets canceled.
The order is canceled. And you, the seller, you've lost the money and you've also lost the product because it's already in a box on its way to the customer.
So success here isn't really about being a great marketer. It's about having perfect technical hygiene, stick-me matching, location mapping, and making sure those API calls are top priority.
It's all about the back-end plumbing.
Which brings up the money. TikTok takes a commission, so sellers often want to charge a higher price on TikTok Shop than on their own website.
Of course. And to do that, you need another technical layer specialized tools that use Shopify's price lists to apply logic. Like, if the sales channel is TikTok, use the TikTok price list, which might be 10% higher.
So that leaves a really interesting question for anyone listening who runs a brand. How does setting up a public different price for the same item across major channels? I mean, when your customers can so easily compare, how does that affect their trust and their loyalty to your brand in the long run? It's a risk you're building right into the architecture.
Okay, let's get into it. Today we are doing a deep dive into the technical architecture of Amazon's Buy with Prime. Our mission here is to figure out how it integrates, or maybe more importantly, how it doesn't integrate with your e-commerce store. Because, it's not like Apple Pay or PayPal. Those live inside your checkout. Buy with Prime. It lives right on the product page, the PDP.
And that's the key. That placement completely changes the game. It is fundamentally a checkout bypass.
A checkout bypass.
Exactly. Think of it like this. When a Prime user clicks that button, a modal pops up and they complete the entire transaction right there inside Amazon's system. They never see your cart. They never see your actual checkout page.
Wait, so the order is placed, inventory is technically reserved, but the customer hasn't even hit the merchant's own checkout.
Not at all.
That seems risky from a control perspective.
It is, and it has huge implications. Any of that critical logic you've built, like, say, block P.O. boxes or your special VIP discount, none of that runs. It can't. Amazon's transaction doesn't know it exists.
So you're basically flying blind until the data syncs up.
Yeah.
This must be that ghost order concept I've read about.
That's the one. The official BWP app has to do all the heavy lifting to tell your store what happened after the fact. So Amazon pushes the order details over to your store through an API.
Okay.
Shopify then creates the order. It marks it as paid, obviously, since Amazon handled the money, but it starts as unfulfilled.
Right.
And crucially, it decrements your inventory count for that CU right away.
And the loop closes when the item actually ships.
Right. When Amazon's multi-channel fulfillment, or MCF, ships it, the tracking number gets pushed back into that Shopify order so it all syncs up eventually.
But getting that button to even show up in the first place, that's a whole other challenge, right? The requirements are really strict.
Oh, extremely strict. The SKU, the stock keeping unit in your Shopify store has to match the CU in Amazon Seller Central.
Exactly. No wiggle room.
None. And the product has to physically be in an FBA warehouse. If either of those things isn't true, the button just doesn't appear. And this leads us to, I think, the biggest pain point for merchants. discounts.
Because your Shopify discount engine is part of the checkout that gets bypassed.
Precisely. It sees nothing. So all those complex rules you built, you have to go into the Amazon Merchant Console and rebuild every single one as a buy with Prime promotion.
You lose that central point of control. It's a huge operational lift.
It really is. It's why the best practice, even now, is to use BWP for, single item hero products. Keep it simple. Avoid that whole mixed cart problem.
Okay, but there is some good news, especially around customer data, right? That was a big concern early on.
Yes, that has changed, thankfully. Amazon now passes the customer's name, email, and their shipping address back to Shopify.
That's a game changer. It means you can actually market to them.
Totally. The BWP app tags the order, so you can just pipe that data straight into a tool like Klaviyo and build a Prime Buyer segment. You own that relationship.
And you can get more granular with where the button shows up too, can't you?
You can. If you want to avoid confusing people, you can actually go into your theme's code like main-product.liquid or something similar, and you can program the button to only appear on products that you've specifically tagged with, say, FDA inventory.
So when you boil it all down, the trade-off is, well, it's pretty clear.
Mm-hmm.
You get the speed, you get the incredible trust and conversion lift of the Prime brand.
But you're giving up control, centralized control over your discounts, your checkout logic, the core of your store, really.
It's a massive architectural decision.
It is. And that brings up a really interesting long-term question for you to think about. Since that rigid SKU match is mandatory for this whole thing to even work, what are the bigger strategic implications of forcing SKU consistency across all of your sales channels, not just Amazon? That one technical requirement could end up changing your entire inventory strategy.
All right, let's dive right in. So imagine you're an e-commerce brand and you're selling on, let's say, TikTok Shop or Amazon.
The high-fee channels.
Exactly, the ones that take a big cut. You need to raise your prices there to protect your margins, but you can't just hike prices everywhere.
You'd absolutely kill your primary website sales.
Right. So today we're looking at this this really clever architectural hack to handle that.
It's a fascinating use case. It's really about repurposing a platform feature that was never, intended for this. We're talking about Shopify markets.
The feature for setting up different regions, like a Germany market or something.
Precisely. But instead of using it for geography, we're using it to create different pricing for different sales channels.
So the core move here is creating a whole new market, one you might call, say, external channels.
And this is the critical part. It has to be headless.
Headless, meaning there's no domain, no actual storefront attached to it.
Exactly. It just exists as a sort of reference point for an API.
Yeah.
It keeps that higher price completely quarantined from your main site.
And then you just go into that market settings and define a price adjustment.
That's it. You go into products and pricing, you set a price adjustment, maybe a blanket plus 15%.
So my $100 shirt on the website becomes what, $115 in this ghost market?
Or maybe $114.99 if you have rounding rules enabled. It's a very clean way to build in that margin recovery.
Okay, that sounds almost too easy. What's the catch?
Well, there is a pretty big technical gotcha. The problem is that most of the native apps...
The default integrations for TikTok, Google, that sort of thing.
Yeah, exactly. They're, let's just say they're a bit lazy. They are hardwired to only pull the price from your primary market.
So they completely ignore this custom channel market you just built.
They don't even know it's there. So, no, this is not a plug-and-play solution.
So then how do you get that $114.99 price to actually show up on Amazon or TikTok?
This is where you need more powerful tools. You need enterprise connectors or specialized third-party middleware.
Things like AfterShip Feed or SaidCommerce, those platforms.
Precisely. And you have to go into that middleware and explicitly configure it. You tell the tool, hey, sync prices, but fetch them using the context of the external channels market.
Ah, okay. So the middleware acts as the smart bridge that knows where to look for the right price.
It's the critical piece that makes the whole strategy actually work.
All right, so the mechanics are set. But what about the shopper? If they see a 15% price jump, aren't they just going to open a new tab, check your website, and abandon the cart on the channel?
That is absolutely the risk. Which brings us to another layer of strategy. This is more about conversion psychology.
Okay, I'm with you.
You set a high universal compare-it price, or MSRP. Let's say you set it to $150 for that $100 shirt everywhere.
So on my own website, the customer sees was $150, now $100. A really good deal, 33% off.
Right, but then on that high-fee channel, where your price is now, say, $120,
The customer still sees was $150, now $120. It still looks like a discount, 20% off.
that's the brilliance of it. The shopper focuses on the perceived deal, on that percentage off, not on the small price difference between your site and the channel. It just reduces that friction to price check. So when you really connect the dots, this whole approach to margin protection, it's not about changing the base product data at all. It's about manipulating the price context that the channel receives.
You're creating these ghost prices that only certain systems can see.
You've got it.
And that, I think, brings us to a really crucial final thought. The complexity of managing these overlapping markets means you have to be so careful. When you're verifying things in your admin panel, you might be looking at a price that no real customer will ever see.
Because you're not in the right context?
Exactly. You have to be absolutely certain your internal checks are pulling from the right context, because one simple administrative misstep could launch a catastrophic pricing error out into the wild. And that final level of caution is really the last piece of protection you have.
Okay, let's just jump right in. We're going to be unpacking the architecture of Shopify collabs.
Right.
Specifically, how you can finally stop using those clunky third-party apps, the bolt-ons, and build something genuinely native.
And that word native is everything here. The old apps, they basically just guess a sale happened. They see a pixel file.
They hope, right. They just hope it's connected.
Exactly. But Collabs is different. It flags the user's actual session when a creator link gets clicked. But here's the real magic.
Okay.
It stamps that attribution directly onto the order object.
Ah, so it becomes part of Shopify's permanent sales record. It's not a guess, it's a fact.
It's totally reliable. And speaking of reliability, it solves the biggest operational problem, payouts.
Oh, the manual payouts, that weekly nightmare of exporting PayPal CSV.
Son, it connects directly to Shopify billing. The whole process is just, it's automated. The foundation is so much more solid.
So with that foundation set, the next step is structure. I mean, you can't treat every single creator the same way, can you? So tiers, why are they so architecturally vital?
Well, because your goals for each group are different. Think about Tier 1. That's your affiliates.
The masses.
Yep. Auto approval, low barrier to entry, maybe a 10% commission. The goal here isn't really huge sales.
That's SEO, right?
Yeah.
Backlinks and long-tail traffic.
Exactly. But Tier 2, the ambassadors, that's where it gets really interesting.
Okay, so these are people you're actually vetting. You're checking their Instagram handle, their reach.
You are. And you give them more. Say 15% commission plus seeding.
Free gifts, free product.
Right. Because now the goal is high-quality user-generated content, UGC.
Engineering that gifting flow, that seeding process, can be a total landmine operationally, though.
It can be. But Collabs automates it by creating a $0 order for the creator. It's brilliant for scaling up.
Okay, but here is the big warning for anyone listening. A huge accounting tripwire. Your inventory software, your ERP, it has to know what to do with those $0 orders.
Oh, absolutely.
I heard this one story where they were all flagged as fraudulent sales. It completely wrecked their weekly reports.
That's a disaster. You have to tag them. Something like channel, collabs, so you can filter them out of revenue reports. It's critical.
So moving on to getting them into the program, the application, it shouldn't just be an email field.
No, you have to treat it like a really smart lead form. Collect the data you'll need later.
Like what?
PayPal email, obviously. But what about t-shirt size? Or even skin type if you sell cosmetics?
Of course. So you can do personalized gifting down the line without 100 back and forth emails. You just have the data in their creator profile.
It makes everything so much more efficient.
But that brings us to the big conflict. I call it the attribution war.
The link versus the code.
Exactly. So say I click the tracking link from creator A, I'm browsing, but right at checkout, I use a discount code I have from creator B. Who gets the credit?
Well, when you look at how Shopify's logic works, it's pretty clear. The sources show that the discount code usually wins.
It wins the war.
It wins the war.
Yeah.
It's seen as the final, most direct action the user took before buying.
So the smartest strategy is really just to avoid the fight altogether.
How do you do that?
By assigning unique discount codes that actually match the creator's handle. It just streamlines the entire thing.
So really, when you put it all together, what does it mean? Collabs lets you build these incredibly efficient programs, sure. But the real genius is in understanding and handling the edge cases.
Right. It's knowing that a $0 order isn't fraud and knowing that the discount code is probably going to beat the link.
That's where the power is.
So that leaves an important question for you listening to this. We talked about that Gold Ambassadors tier, 20% commission, personalized codes like first name 20. If you were designing your own ultimate custom tier, what other data points, beyond just size or skin type, would you absolutely have to collect in that application form to build the most personalized and powerful program possible? Okay, let's unpack this deep dive into modern loyalty engineering, because for way too long, being loyal has just felt like this high friction game.
Oh, totally. That old spend $1, get 1 point model. It was less of a reward, and more like having to do paperwork just to get a coupon later on.
Exactly. What we're seeing now is a huge architectural shift away from those, transactional points and toward this idea of an automatic status.
It's all about instantaneous recognition. If you are a gold member, the benefits should just apply. No work needed.
And that's the core objective for today. We're going to break down how to actually build a system where a customer, say with a total spent over $1,000, automatically gets 15% off.
Instantly. At checkout.
Right. And it's not about coupons. It's automated recognition. And it's built on really 3 fundamental pillars.
And pillar 1, you have to start here, is the data layer. The thing is, the native total spent value. It isn't something you can easily access inside that real-time discount logic.
So you need another place to store it. A stable source of truth that the function can read.
That's it. So you create a dedicated meta field right on the customer record.
Okay, so specifically, we're defining it with a namespace of loyalty and a key of tier.
Yep, with values like gold, silver, bronze. That meta field is now the definitive signal of their status. It decouples it from the raw spending data, at least for the discount engine.
All right, so we've got our single source of truth in the meta field, but that data isn't static. It has to be updated somehow.
And that's pillar 2. This is all about the automation piece. You need a rule engine, something like Shopify Flow, to handle that for you.
We picked Flow because it's dedicated. It's low code, it's native, and it keeps the latency for these updates really low.
So we tell Flow, okay, listen for any new order. The trigger is just order created.
As soon as that order comes in, a condition immediately checks that native field. Is the customer's lifetime spend now, greater than $1,000?
And if that condition is met, the action is simple. Update that customer's meta field. It instantly sets their loyalty.tier to gold. Flow is just keeping that status correct for you automatically in the background.
Right. It's handling that status management behind the scenes, so when the customer comes back for their next purchase, the data is already current. You're cutting out all that admin overhead, and you're basically setting the stage for pillar 3.
And this is where it gets really interesting. Pillar 3 is the function logic. This is the code, the product discount function, that runs in milliseconds during checkout to actually grant that discount.
But how does the function know the customer is gold? It still needs to look it up.
It does. And to run, the function needs that data. The input query for the function has to explicitly ask the cart for that specific loyalty.tier meta field from the customer.
So if you don't ask for that specific piece of data, the function is essentially blind.
Totally blind to the customer's status. But once it reads that the tier is gold, boom, it assigns the 15% discount. If it's silver, maybe 10%.
And if there's no tier?
It just returns an empty discount. Nothing happens. And this is what creates that seamless user experience. An anonymous user, they just see standard prices. But the moment they log in,
the function runs, the price just drops, and they see that immediate value.
And what's more, that function can also inject a message field. Something like, VIP status, Goldie member 15% off, that shows up right next to the discount.
Oh, that's huge. That little message constantly reinforces the value. It keeps them engaged with their status.
So once you have this status architecture built with meta fields and functions, the possibilities are, well, they're huge. You control all the logic.
You control who gets what instantly based on any rule you want to define. You could flip this whole thing on its head. Think about something like an owner's discount.
Exactly. You could use the very same function structure, but instead of checking a meta field,
you just modify the input query to check for a customer tag instead.
Yeah, that's the ultimate flexibility. We just check if the customer, say, has any tags GOG's owner.
And if that tag comes back as true,
the function grants an instant 99% discount. And that just shows the incredible power you get when you shift from these rigid old loyalty engines to custom instant logic that executes right at checkout. That control, that's what defines modern commerce.
So today's deep dive is all about the architecture of tiered memberships. Specifically, that challenge of the velvet rope. We're talking about the technical side of gating, how you show an exclusive product, but then mathematically refuse to sell it to the wrong person.
Exactly. It's all about managing scarcity with code.
Yeah.
And you really see three main ways companies approach this.
Okay.
First, you've got the soft gate. That's the gentle one. It just says log in to see the price.
All right.
Then there's the hard gate, which is much more direct. It's a wall. It says VIP only. You cannot buy this.
And the third.
That's the time gate. This is for those early access drops, available to the public in 24 hours.
And the really critical thing here, the core engineering insight, is that you need two totally separate layers to make this work.
You do. You need the user experience layer, and then you need the real security layer behind it.
So let's talk about layer one,
Yeah.
front-end gating. That's the UX piece, right?
Right. That's the polite velvet rope. It's just code, maybe some liquid that checks if you have the right customer tag, like VIP access.
And if you don't have the tag, it just doesn't show you the add to cart button.
Exactly. It stops the casual, honest shopper. It's there to manage expectations. So if you're logged in, but you're, say, a silver member, you'll see a message.
Something like, gold members only. Spend $50 more to unlock this.
That's the idea. It guides you toward that next tier.
I'm with you, but I guess my question is, why isn't that enough? If you've hidden the button and put up a warning, seems like that would handle 99% of people.
It does, but it's that 1% you have to worry about, the tech-savvy user who sees this as a puzzle to solve.
Wow.
They don't need your button. All they need is the item's ID. They can just go to the URL and add something like cartad.id 12345 at the end.
And it just bypasses the whole product page.
It bypasses everything you've built on the front end and sneaks the item right into their shopping cart.
So that's the frustrated hacker who suddenly hits an invisible brick wall at checkout.
That's the goal. And that brings us to layer 2, back-end gating. The real security, the non-negotiable part.
Okay, so this is the steel vault.
It is. And the clever part is you reuse existing server logic. There's something called the cart validation function.
Which runs when?
It runs on the server the moment you hit checkout, after the item is already in your cart. It scans every single item for a restriction tag, like VIP.
And then it checks the customer to see if they have the matching access tag.
And if they don't, it returns a blocking error. The purchase becomes, mathematically impossible. It doesn't matter how they got it into the cart.
I do appreciate the efficiency of that, reusing core logic instead of building a whole separate firewall. But does that risk making the checkout path, which is so critical, too complex, or slow?
That's absolutely the trade-off you make. It's a very small performance cost, but it's for a huge gain in security. If you want true exclusivity, you have to block it at the final point of sale.
Right.
And the validation function is really the only reliable choke point to do that.
What's fascinating to me is how this applies to the time gate, that early access challenge. You can't have someone sitting there at midnight manually removing tags from products.
No, that would be a disaster. So that's all automated using metafields.
Metafields.
Yeah, it's just a small piece of data you attach to the product, something like launch.publicdate that has the exact time it goes public.
And the front-end code just compares the current time to that timestamp.
That's it. If the current time is before the public date, the regular buy buttons stay locked for everyone but the VIPs. It automates that whole 24-hour head start.
So tying this all together, what this really means for you is that any successful tiered membership system absolutely depends on having both of these layers working together.
You need both. The front-end UX to be the friendly gatekeeper.
And then that unyielding back-end validation function to be the actual security.
Right. If you forget to implement that server-side layer, your whole exclusivity system is, it's basically just for show. It has a huge hole in it.
It's a really great piece of architectural planning. And considering how necessary these complex dual-layer systems are just to protect a single click, it raises a bigger question for you to think about. What other areas of the digital experience outside of just purchasing might benefit from having both a visible UX gate and a hidden server-side validator to protect scarcity or exclusivity? Think about that next time you see a VIP product page. All right, today we're diving deep into the final review of a major e-commerce data science course. We're focusing on this technical architecture they call the growth stack. It's really a roadmap for how top companies keep growing, even with all the new privacy tools out there.
That's right. And our mission today is pretty straightforward. We're going to quickly map out the 4 key layers of this architecture. Then we'll get into the ultimate goal, what they call the golden record. And finally, internalize the 3 big rules from the Architect's Manifesto.
And the foundational idea here is simple, but also pretty brutal.
It is. The system has 4 layers. If any single one of them fails,
Your revenue drops. It's a chain. And if one link breaks, the whole thing falls apart. Loss everywhere.
Okay, so let's unpack this, starting with the layers and the problems they're actually built to solve. Layer 1 is the data layer.
And its main job is solving what's called signal loss. I mean, you have to think of the user's browser to a fundamentally hostile environment.
You're talking about ITP, ad block, all those privacy settings. Exactly. If you're only relying on the browser, your attribution just dies on the vine.
So the solution is to move tracking. Where? Server side.
Entirely. You use things like SAPI and consent mode v2. It means even if the client-side pixel fails to fire, you still have a secure, verifiable data packet going straight to the ad platform. You bypass the hostility.
Okay, so let's jump ahead to layer 3, the retention layer. The problem it solves is anonymity.
Right, and this is where identity resolution comes in. It's about building a kind of digital fingerprint for a user before they even get to the cart.
Interesting. So you're not waiting for them to check out to know who they are.
Not at all. The shift here is fascinating. You're using tracking history, AJX listeners, things like that, to identify them early. And that means you can trigger messages based on their site behavior, not just waiting for their purchase history.
And that leaves layers 2 and 4. Layer 2, the traffic layer, is all about relevance, right? Using custom feeds to make sure the ad matches the landing page perfectly.
Precisely. And layer 4, the logic layer, tackles friction. That's where you use tools like Shopify functions or Flow to automate complex rules like for loyalty or pricing. You're moving from manual work to algorithmic profit control.
So if the layers are all this machinery, what's the actual product we're building? That gets us to the big goal, the golden record.
The golden record. It's defined as this single, unified customer profile. It merges every single data point you have on them.
So their email,
any preference data from a quiz, their entire server-side tracking history, their loyalty tier, it's all in one place. Their complete digital identity.
And that matters because it changes marketing from just, blasting out mass emails.
So actually having a conversation with your data. You're using those specific granular data points to connect with them at scale.
Which brings us to the guiding principles for the whole thing. The Architect's Manifesto. Rule number 1 is pretty blunt. Don't trust the client.
It sounds aggressive, doesn't it? But from a technical point of view, it's essential. You have to assume the browser will try to block you.
So everything needs to be tracked and validated on your own server.
Everything. If you trust client-side data, you might as well just be throwing your tracking investment away.
Okay, rule 2 is about control. Own your data. This feels like a big strategic move, not just a technical one.
It is. It means you avoid those black box third-party apps that hold your identity logic or your custom feeds hostage.
Because if that app shuts down tomorrow,
your entire growth engine shouldn't crumble with it. That independence is it's non-negotiable if you really want to scale.
And the final rule? Latency kills. But the source material says this is more than just page speed.
Much more. It calls speed the currency of conversion. It's not just a slow page load. It could be a slow pixel firing or a 2-hour delay syncing inventory to your ad platforms. Any friction, any delay translates directly to lost revenue.
So what does this all mean for you, the listener? The course wraps up with this final thesis challenge. It's the ultimate test.
It is. You have to imagine tracing a single user journey. Let's say a B2B VIP customer from France. They visited your site from a TikTok ad, but they didn't buy anything.
The first checks are obvious. Did they see the right B2B catalog, the right currency? But the real test is tracing that data flow through the stack we just talked about.
Exactly. You have to be able to answer. Did the server-side tracking fire and successfully deduplicate, overriding any browser block?
And this is the crucial part. Did we successfully connect that anonymous TikTok click using our identity resolution system all the way to a known identity in our golden record? If you can trace that entire journey and verify that the data survived that hostile environment, then you're ready to go build something massive.